AP Calculus AB, looking at homework 1.3, find the value of each limit. If the limit does not exist, state why. So for this problem, we are supposed to take this limit as h approaches 0. We're supposed to take the function f of x here at the beginning and replace every x value with an x plus h. That's going to be 3 times the sum of x and h squared minus 2 times the sum of x and h. That represents this part here. And we're supposed to subtract from that the original function f of x, which is 3x squared minus 2x. Now we can't evaluate this directly because we'd be dividing by 0. Let's try to simplify the numerator and see if we can factor an h out of it. X plus h squared is x squared plus 2hx plus h squared. If you multiply that by the 3, you're going to get 3x squared plus 6hx plus 3h squared. Distribute the minus 2, we get minus 2x minus 2h minus 3x squared plus 2x. 3x squared and minus 3x squareds cancel. Minus 2x and a plus 2x cancels. We're going to get 6hx plus 3h squared minus 2h in the numerator. If we can factor an h out of the top now, get the limit as h approaches 0 of h over h times 6x plus 3h minus 2 over h. H's cancel. Keep in mind, we have to keep writing a limit notation until we evaluate the limit. We can now evaluate the limit. We can put a 0 in for all of the h's and get 6x plus 3 times 0 minus 2, which is 6x minus 2. Number 2, we have this limit as x approaches 2. Now we are supposed to take the original function, h of x, put that at the beginning, and we're supposed to subtract from that the original function evaluated at 0. That's going to be 0 squared plus 2 times 0 minus 3. If we simplify this, we're going to get the limit as x approaches 2, x squared plus 2x minus 3 plus 3, because this is 0 plus 0 minus 3. A minus minus 3 is a plus 3. 3's cancel. We get the limit as x approaches 2 of x squared plus 2x. We can factor an x out of the numerator. X cancels from the top and the bottom. So now we have the limit as x approaches 2 of the sum of x and 2. And to evaluate the limit, we put a 2 in for the x. Once you put that in, you do not have to use limit notation. The next several problems have the same instructions. If the limit of f of x as x approaches 3 equals 2, and the limit of g of x as x approaches 3 is negative 4, find each of the following limits, show your analysis applying the limit properties. So this first problem we could rewrite. We can take this coefficient out to the front, so it's 5 times the limit of f of x as x approaches 3. divided by the limit of g of x as x approaches 3. So according to this f is going to approach 2 as x approaches 3. And according up here, g is going to approach -4 as x approaches 3. So that's 5 times -1/2, which is 5 over -2. Number 4, we could rewrite this as the limit of f of x as x approaches 3 plus 2 times the limit of g of x as x approaches 3. According to the instructions, f of x approaches 2 as x approaches 3, and g of x approaches -4. That makes this -6. Number 5, let's see, we could write this as, first of all, what's the square root of 4? It's 2. So this here we could write as the square root of 4 times the square root of f of x, and the square root of 4 is 2. We can put that out front. We can take the limit as x approaches 3 of f of x, and once we find that answer, square root it. The limit of f of x as x approaches 3 is 2, so that makes this 2 square roots of 2. Number 6, we could write this as 1/8 times the limit of g of x as x approaches 3. The direction says that this limit is approaching -4, so it's 1/8 times -4, which is -1/2. Number 7, we could write this as 3 times the limit of f of x as x approaches 3 minus the limit of g of x as x approaches 3. This would be 3 times 2 minus a -4, which would be 6 plus 4, which is 10. Number 8, we could pull this 1/12 out to the front and say this is the limit of g of x as x approaches 3 times the limit of g of x as x approaches 3. I might have said g here, I meant to say f. That's going to be a 12th of 2 times -4. Let's see. 2 times -4 is -8. And you can reduce that to -2/3. 4 more. Different instructions now, different limits. As x approaches 4, f of x approaches 0, and as x approaches 4, g of x approaches 3. So we could write this next one, if we were so inclined, as the limit of g of x as x approaches 4 over the limit of f of x as x approaches 4. And then when you're done, subtract 1 from that. So the limit on the top approaches 3, the bottom one approaches 0. So it's going to be 3 over -1, which is -3. Number 10, this would be the limit of x as x approaches 4 times the limit of f of x as x approaches 4. What does x approach as x approaches 4? It approaches 4. What does f of x approach? According to the instructions, it approaches 0. 0 times 4 is 0. Number 11, this will be the same as what's the limit of g of x as x approaches 4? When you're finished, add a 3 to it. The limit of g of x is 3. Add 3 to that, you get 6. Last one, the limit of g squared of x as x approaches 4, we could write as the limit of g of x as x approaches 4. And when you're done, square it. So that's going to be 3 squared, which is 9. All right, that